Hello everyone, welcome to my new video. Today we'll discuss about the center of mass, the part from the rotational dynamics. It is very important topic, and here is a two important formula to calculate the center of mass for the discrete mass. Here this formula is applied for the discrete mass, and this formula is applied for the continuous mass is given. And here is one important things: the center of mass is as it is if external force is not changed. If we are not applying the external force on the that system, and then there is no change in the center of mass. Only external force is responsible to change the center of mass. If there is the intermolecular force of attraction or any internal changes in the system, that does not create change in the center of mass. So for to change or to get the value of center of mass, we need to apply the external force on that system. There is no role of internal force to change the center of mass. Here, the location of center of mass is very important. Location of center of mass is unchanged in rotatory motion. And first of all, we know that what is rotatory motion? Rotatory motion or translatory motion? Translatory motion that refers that kind of motion, and rotatory, which is rotation, it of the rotational motion. We'll discuss it in next video. But the center of mass today we are discussing, so that location of center of mass is unchanged in rotatory motion. If motion is rotatory, the location of center of mass is unchanged. But if the motion is translatory, the location of center of mass is changed. Here, in rotatory motion, the location of center of mass is unchanged. In translatory motion, the location of center of mass is changed. Here, we discuss about the center of mass for the ring, half disc, hemisphere, solid hemisphere. Center of mass for ring. Suppose it is ring, and the center of mass for this half ring is, it is half. Here is half. This is half ring, and the center of mass for the half ring is 2r upon pi. Here r by pi is as it is. For the half disc, there is 4 by 3. 4 by 3, and here is less center of mass. Here is more center of mass in comparison of half disc. In the half ring, there is more center of mass. Here 2r upon pi. To remember, r by pi is as it is in both half disc and half ring. Here is 2 and here is 4 by 3. And then for the hollow hemisphere, for easiness, we remember that here for the solid hemisphere 3 by 8 by r, and here for the hollow hemisphere it is 1 by 2 r. Here for the for 2 easy, we also can remember by 4 by 8, which is 1 by 2 and 3 by 8. 4 by 8 r for hollow hemisphere and 3 by 8 for solid hemisphere. Center of mass of ring 2r upon pi. Center of mass of half disc 4 by 3 r upon pi, and for hollow hemisphere 1 by 2 r or 4 by 8 r. For solid hemisphere 3 by 8 r. Here is the some important points about the center of mass. For more clarify about the center of mass, we must know about the sum of moment of mass for particles about center of mass. Sum of moment of mass for a particle about center of mass is 0. The moment of mass for particle about center of mass is 0. Moment of mass for particles about center of mass. Particles, which is about center of mass, is its moment of mass is zero. Center of mass COM describe the translatory motion because in the rotatory motion the center of mass is unchanged, but in translatory motion the center of mass COM is changed. That's why we can say that center of mass describe the translatory motion. And here is one important point: if the cell is moving in the parabolic path, is flying, and it's if it discrete into the number of pieces, they also their pieces also follow the parabolic path. And if the initially both particles are at rest and the velocity of center of mass is zero. If initially both particles are at, the velocity of center of mass is zero. Here is the four important points about the center of mass. We will discuss more points here. The center of mass depends upon the mass of the system. If the mass is different, if the different mass for the different mass, center of mass is different for the different object. And the position also matters in for the center of mass and relative distance between the particle. The particle distance is also matter for the center of mass, but it is independent for the force of the particle, that is internal force. Particles of force is internal force, so it is independent for the center of mass, but it depends upon the relative distance between the particle. The distance between the particle, it depends upon the center of mass. And here is one more: the center of mass of thin triangular plate lie on its centroid. For the thin triangular plate, the center of mass lie on the centroid. Here is centroid. In the centroid, the center of mass is lie. Dependent mass, position, relative distance between particle, but independent in the force of particle. Here, actually, the what is the center of mass? It is a point for a body or system where the entire mass is assumed to be concentrated. If this is a rod, and in this point here we assume to at the center, we assume that if they are uniform rod, and at the middle we assume that here is all mass of the body is concentrated here. That point is called COM. It may lie or may not lie in within a body. It may lie or may not lie. It is a point for a body where the entire mass of body is assumed. We assume that all the mass of the body is concentrated here. That is the center of mass. COM.